guys, welcome back. I want to take a look at factoring today because if you've been in algebra very long, you know that you have a lot of factoring, and that's whether you're in Algebra 1 or Algebra 2 or really trig or really calculus or wherever. So let's start at the very beginning of factoring and get a very good foundation. In this download, we're just going to be talking about greatest common factor, so let's get going. I always try to connect back to arithmetic, so back to arithmetic just for a minute. You know how you would have 2 times 3 is 6 in arithmetic, and you would learn that these two, the numbers that were multiplied together, were called your factors. And then the number that you got would be called your answer or your product. And so that's multiplication, no problem. And then later on in arithmetic, you learn to work that backwards. It's like dividing, really. You would take your answer, and then your teacher would ask you to break that down as far as you could. And sometimes you would use a tree, factoring tree, and you would break it down. And then when you break it down again, and so you would break it down as far as you could until it was just prime factored. There's nothing else other than 1 that you could break it down to. So we would stop here and we would know that these 3 numbers would be our factors. Well, we're really going to do the same thing in algebra that we did in arithmetic, the very same train of thought. So we're going to start with something like 2x plus 6, which you know by now is a binomial. The coefficient of x is 2, and 6 is what you call a constant term. So we're going to look at both of these two terms. We're going to say what number will go into both of those. You're right, 2. So that's our common factor. We take out the 2. We say we take out the 2, meaning literally we write it out here. And then we divide it and see how many times it will go into each term. Well, 2 will go into 2 one time, so we just have x because you already know that you don't have to put the 1 in front of x unless you just want to. And then you've got positive, and then 2 divides into 6 3 times. And this will not break down any further. So this is the factorization of 2x plus 6. It's broken down with the greatest common factor of 2. And sometimes you will see this written G for greatest, C for common, and F for factor. Greatest common factor. Suppose you have an expression like XA plus 3XB minus 2XC. Okay, this time you know that you've got a trinomial. You know that the numerical coefficient here is 1, the number in front. The numerical coefficient here is positive 3. The numerical coefficient here is negative 2. And so you want to look first at your numbers and see is there any number greater than 1 that will divide into all 3 of those. Well, if that's a 1, a 3, and a 2, there really is nothing that will go into all 3 of those. So, okay, it doesn't have a numerical common factor. So now we look at our variables. We have an x here, an x here, and an x here. So they all have an x in common. This is a good thing. Yay. Then we look at a. That has an a, that doesn't, and neither does that. This one has a b, but that one doesn't, and neither does that. This has a c, but neither do these two. So the only thing it really has in common that they all have really is the x. So we say, well, in that case, x is our greatest common factor. So we remove it, we pull it outside of our parentheses, and then we divide it into each term. We've basically taken the x out and divided it, and we have a left. We've basically taken the x out, and we have left 3b. And we've basically taken the x out, put it out here, and we have left negative 2c. Because this x goes with and is multiplied by each one of these. So we're complete. We're finished with that problem. We can always check it by multiplying back and saying, okay, that would be xa, yes. That would be positive 3 times xb, yes. And that would be negative 2xc. If we distribute it back, we can check it that way. So all is well, and that's all there is to that problem. All right, so you can see that sometimes your greatest common factor is a number or a constant. Sometimes your greatest common factor is a variable. And sometimes it can be both. So let's take a look at this one. Let's say we've got 12x squared y. Let's say we've got positive 6 x to the third power, y to the second power. And now let's say we have negative 4 x, y. Let's just say x, y. Okay, so now again we have a trinomial. We have 3 terms. The numerical coefficient here is 12. The coefficient here is positive 6. The coefficient here is negative 4. Okay, so we look at just those numerical coefficients and we say, what number will go into all of those? In fact, what is the greatest number that will go into all those? So we say, okay, well, we'll go into 12, we'll go into 6, we'll go into 4, and we're like 2. 2 will go. And really, 2 is the only thing that will go into all of those. So that's our numerical greatest common factor. Now we look at each variable separately. We look here, we've got x squared. So we've got x times x, got 2 of them here. We've got x's here, we've got 3 of them. X times x times x. And here we really only have 1 x. Okay, because if there is no exponent, we know there's only 1. So we say, well, if there's 2 there and 3 there and 1 there, they all have at least 1 x as a factor, correct? Yeah. So that's all we can take out is what they have in common. You might say, well, that one has 3, yeah, that one has 2, but this one doesn't have 3. They have to have that in common. Though they all have at least 1 in common. So we're going to take out the 1x, just 1x, see, x to the first power, 1x as a factor. Now let's do the same thing with y. We've got a y, 2 y's, and 1 y. So the most that they all can claim is 1 y. So 2xy is our greatest common factor. So let's divide that. It's outside of our parentheses. It's the first term. Now let's divide it into each one. 2 divides into 12 6 times. And we've taken 1x away from the x squared because when we divide exponents, you will remember, we subtract exponents. So 2 minus 1, so we have 1x left. We only had 1y, we took out 1y, so there's no y's left in the first term. Okay, you with me? Okay. 2 divides into 6 3 times. Notice I used the same sign. I took 1x out, so I have 2 left. I took 1y out, so I have 1 left. I'm simplifying some of the verbiage so that this will just flow a little bit easier for you. 2 divides into 4 2 times. Notice I used the same sign, that minus right there, that negative. I took 1x out, so didn't have any x's left. I took a y out, so I didn't have any y's left. So my final answer is, I don't want to mark that x out, 2xy is the greatest common factor. And then what I have left is 6x plus 3x squared y minus 2. And that expression has been completely broken down as far as it will go. This is just one type of factoring. There's several, and we'll try to go over all of those. But this is the type that you always try first. Okay? And I'll say that many, many times. But let's look at this one right here. I like to throw a simple one in. Here we go. Let's suppose we have ax plus bx plus cx. And just for practice, you look up there and you say, what is the greatest common factor? What do all 3 terms have? You look up there and you say, well, they all have an x, so the greatest common factor is x, so you take out that x, and then you simply write down what is left when you've divided that out. And what you have left is an a, same signs, b, and c. And so that trinomial and that expression has been factored to lowest terms. Sometimes you will have one like negative 5xy plus 3y, let's say. And you look at that and you say, well, they both have a y, so that's a good thing. And you look at the 5 and the 3, and you say, well, they don't have anything in common there, and you're right. But you see that negative? And we don't usually like to lead off with a negative. So if a negative is there, kind of like we manipulate that a little bit, really truly, just to get rid of that negative look. And we factor out a negative 1. Because if we do that, it would change all of the signs, like so. We factor out a negative 1, and they both have a y, don't they? So let's also make sure that we take out the y. So the greatest common factor is negative 1 y. The only time I ever take out a 1 is if it's a negative that I don't want to lead off with a negative. I can take care of that by factoring out a negative 1. They both have a y, so that's out too. So let's see what we have left. The negative is gone, so I just have the 5x left. And then I factored out a negative, so I have negative 3 and the y is out. So here's what we have. We always want to check back, and that's how we know if we're right. So here we go. We go negative 1 times y is negative 1 times 5 is negative 5, and then y times x is xy. Yx, xy, same thing. And then we go again, distributing. Now this is how we check back. Negative times negative is positive. 1 times 3 is 3. And then there's y. So it does check, and it is factored. I just wanted you to see what that would look like. Another example might be something like, you might have a problem, negative x, negative a. And it just might be a time when you don't want it to lead off with a negative. So you can factor out the negative. Teachers will do this all the time. So you factor out the negative, and you don't have to put the 1. You can just put the negative, but I like to put the 1 in this case. I think it's a little more clear. So we take out the negative, and we can't take out any, there are no matching letters and no variables they have in common. So we just have left x plus a. And you'll kind of notice that the signs are changing because that's what happens when you multiply by negative. So let's multiply back through to check. We get negative 1x, yes. And then we multiply, distribute, negative 1 times a, we get negative a, and that checks back. So you'll see this and this used interchangeably sometime. And so if you're having to factor and you've got a negative leading off, it's always a good idea to pull that negative out, factor out that negative 1 to start with. So let's see what we've got. Let's say we've got one with a fraction in there. Maybe we've got something like, let's say 1/4. Get some of this out of the way for you. Let's say we've got 1/4 x to the third plus 3/4 x squared minus 5/4 x. 5/4 x. And you take a look at that. First of all, you got fractions to deal with, but it's okay. It's actually great because they have the same denominator, and that always makes it so much better. So it's 1/4, 3/4, negative 5/4. And if it asks me to factor, then because they're all fourths, I could just factor out a fourth. I can't factor out more than 1 because this only has 1. And remember, they almost share this. So let's say they almost have it in common. But watch, and I think this will clear up for you. And I've got x to the third, x to the second, and x. So I can take out an x because they all have an x, at least 1. So this one has only 1, so that's all I can take out. So now, 1/4 has been taken out. One of the x's has been taken out. So how many x's are left? Right. So you got x squared. Same sign. The sign won't change now unless you bring out a negative, and then it will change. Didn't bring out a negative here, so the sign's the same. So I've got 3/4. I bring out 1/4, so I have 3 left. X squared. I had 2 of them, had x times x. I took out an x, I have 1 x left. Same sign. 5/4, took out 1/4, have left 5. Took out the x, so no x is left. So there you are, and that is what you have left. So even something that looks as messy and complicated as fractions like that can still be factored. And you don't see those all the time, but occasionally you might. So just take a really close look, and that's the lesson. Take a really close look at what they have in common. So let's do one more just to end this, this section on greatest common factor. I really want you to remember that of all the kind of factoring that we're going to talk about, this one is always the one you do first. It just makes it so much easier if you'll get into that habit. Do this one first. So I'm going to make up one that looks kind of complicated, but it really isn't that complicated. So watch, and let's do this one together. Let's say we have 5, a to the third, b to the fourth, y squared minus Let's just make this interesting and say we have a minus to start with. That'll give us a little more practice in leading off with a negative. And then let's say we have negative 10a b squared y squared. And then let's say we have positive 15, and I'm picking nice numbers that we can kind of see quickly and learn from. And so let's say we've got a squared, b squared, and y squared. And we could go on with terms. We've got 3 terms here, 1, 2, 3. Just as review, that's a trinomial. And as review, our numerical coefficients are -5, -10, and +15. Those are our leading off numbers for each term. So let's just look at the numbers and see what's the greatest factor that will go into 5, 10, and 15. And we all see right away, I think, that 5 will go into all of those. And because we're leading with a negative, let's take out the negatives. We're choosing to factor out a -5. All right? Okay. We would choose to if it leads off with a negative. All right, now let's look at our A's. I've got 3 A's here. I've only got 1 there, 2 there. So the most I can take out would just be 1. Couldn't take out more than 1 because I don't have a 1. Okay? Now let's look at the B's. I got 4, 2, 2. So I'm asking you now, how many B's can I take out? How many B's do they have in common? They all have at least how many? Right, B squared. They all have 2 of them. This one has more. Now let's look at the Y's. Same thing. How many do they all have? What do they have in common? Y squared, Y squared, Y squared. Easy one. Yep, they all have Y squared in common. All right, now we have given it our very best effort at writing down everything that they have in common. And we've done a good job. We got the -5, we got the A, and we got the B squared, and we got the Y squared. It's always good to double check and make sure we didn't miss one. Okay, now we're going to divide our coefficients. So -5 into -5 is 1. Don't need the 1. Out of A3, I took 1 out, so I have 2 left. Out of B4, I took 2 out, so I have 2 left. Y squared, I took out, so there are no y's left in that term, because this covers that one. All right, now, if I'm dividing a negative into a negative, I get a positive. So when you factor out a negative, your sign will change, so that when you distribute back, it works. We'll see that in a minute. 5 divides into 10 2 times. I have 1a here and 1a here, so I've taken that one out. I have no a's left to record. I took out 2 b's. I had 2 b's. I have no b's left to record. I have y squared. I took out y squared. I have no y's left to record. It's just 2. Okay, now 5 goes into 15, 3. Negative goes into positive, negative. Divides into a negative times. So 5 into 15 goes -3. A squared, take 1 out, have 1 left. B, there are 2 of them. Take 2 of them out, none left to record. Y squared, took y squared out, none left in that position either. Now, it's imperative, really, really important that we check this back, because we can tell if we're right or not, like right now. So here we go, we distribute back to check. We go that way, we get -5, a to the third, b to the fourth, because I got 2 here and 2 there, and then y squared, so that works. Now I'm distributing -5 over to there, I get -10. And I get a, b squared, y squared, that works. One more time, and I get -15, a squared, b squared, y squared, so that works as well. So all is well, and we have completely and successfully factored using a greatest common factor. There are a lot of different ways that you might see this along the way, but what we've done here today is the basic understanding of what it means to factor something using a greatest common factor. So you'll see it a lot. Greatest, you might want to write that down, common factor. So anytime your directions, your teacher, your book says factor this completely, this is what you try first. It may not work, and if not, then we will go to another kind of factoring. Because if you had 2x plus y, and something like that, and someone asked you to factor it, you would never be able to find a greatest common factor because there is not one. If someone gave you x squared minus 4 and asked you to factor that, and if this was the only way you knew, it doesn't have a greatest common factor. So you wouldn't be able to factor it either. However, there are other ways to factor that can factor this one for us, and that is what we have coming up next. So sit tight. Well, I'll take that back. Go take a break. A little bit at a time. Go take a break. Master this and get totally comfortable with it. Watch it as many times as you need to. And when you're ready, then come back and we'll take a look at the next kind of factoring. Have a great day.